Hey everybody, this is Michael with Gimbel Automation. Today I just want to give you basically the whole normal sales PowerPoint that we regularly take our clients through. Just put it on one convenient place, YouTube and our website, so you can easily get an overview of all the product offerings we have and what we do. So let's get started here. So I like to generally start with the problem that we're trying to solve for machine shops and production floors everywhere. And, generally all shops kind of have the same problems and the same sets of outcomes. And I just like to lay them out one by one. In a perfect dream world, I think every owner operator, every shop foreman, they all want to have more production, which means make more parts. They want to make those greater number of parts with, increased profit margins, greater efficiency overall, with generally less difficulty. And of course, in an ideal world, they want to do that with less labor. And of course, when we say less labor, I think the ideal scenario everyone wants is that you could keep the same head count, but that same head count is doing, much more ideal people-friendly things. So, rather than having an operator press a button over and over, ideally you can have that same operator, instead of running one machine, run 4 or 5 machines, or, improve systems, or generally make your shop, your environment, and your processes cleaner. So, that's kind of the situation everyone's in, and specifically what we're trying to achieve for you. Get you more production, more profit with that production, and achieve all of that with less labor going into an individual component. And one place we like to start is really by talking about all the competing systems that are out there on the market. And when we think of a competing system, really we don't think that there are good direct competitors with us in terms of other systems that are, grippers or in-machine automation. We've really flushed it out and are really, we think, the leaders in the in-machine automation space. But, that said, we have tons and tons of competition in the dedicated robotics, robot-in-a-box, pallet changer space. So we really view, competing solutions to in-machine automation as, say, a Haas pallet changer, or even a pallet changer on a horizontal, or, a robot-in-a-box, whether it's from Halter, Trinity, RoboJob, automation within reach, and of course, any kind of integrated or self-integrated robot or cobot integration. And, the thing I really like to remind everyone of is that all of this traditional automation works and it gets you a good ROI, generally in the 2 to 3 year range. And really, we're trying to take everything from an angle of getting you the same outcome without a lot of the downsides of traditional automation. So, we talk about a pallet system. The first thing that you obviously are going to see with all of these, including the pallet system probably to the greatest extent, is they just take up a ton of floor space. The EC400 here is just a very large machine, but if you take, something kind of regular VF2, UMC, or your typical 3-axis mill, generally speaking, a pallet changer, especially in aftermarket, is going to be as big or equally sized to the mill itself. And then, of course, you have the price, even a low-end pallet changing system that is integrated and purchased with the actual CNC machine. Even a low-end one's going to be at least $75,000. And of course, if you've actually seen one of these pallet changers changing pallets, it takes a couple minutes to change from one setup to another. There's all kinds of different pallet changers, but the very, very low end of things is going to be on the 75 grand range. Maybe 60 grand if you're looking at something like a Mideco that can only swap out one pallet. And you can easily get up to $500,000 once you start getting into the multi-level systems. The next big thing that we view as kind of a competing space within machine automation is these robot-in-a-boxes. And whether that's Trinity, Halter, automation within reach, all of these systems you basically are working by having a giant or sometimes a mid-sized FANUC or industrial or UR robot basically placed in a box where it can do the pallet loading and unloading, or in some cases, for instance, with the Halter, doing individual part loading, more similar to what you would see with in-machine automation. Now, one of the really big downsides with robotic pallet or part loading and these robot-in-a-box systems, the system integration is really complex. Generally speaking, you're not going to be able to just move this from machine to machine. It's going to sit on one machine. The actual integration is going to be $25,000 to $30,000 of your overall cost, which of course is usually rolled into the MSRP of the actual system. And because of that, we'll talk a little bit more about this on the next slide. These really suffer from some extreme depreciation if you want to try to move on to a different system or integrate with a different machine. And then kind of the last option this is the most kind of DIY option and definitely the most cost-effective option on this list. This is a standalone robot or cobot integration. So, really here we're talking about the UR or Doosan, or, whatever cobot you might have, usually combined with, whether it's Vention or, a bunch of these other robot integrator systems, usually combined with, some kind of human-machine interface, HMI, as well as some kind of table and part loading solution. Generally speaking, the robots themselves at the very low end are going to start around $30,000 just for the base robot. Then, of course, you have to add the work holding device, usually an auto door if there's not one already on the machine. And because of this, we're still looking between $65,000 and $150,000 for a cobot solution. You can be very close to the low end of this if you're doing everything self-installed, but that's generally about the range with a robot or cobot. Robots have the big advantage over cobots in that they're a lot more industrial, a lot more precise. The joints last a lot longer. But of course, they have the pretty obvious known downside of having to have, proper safety fencing, whether that's, very high-end light curtains, or most likely just a standard kind of robotic cage. So, now I want to talk about the downsides of these traditional automation systems compared to machine automation. And, the first and most obvious one is just the very high upfront cost. They're super nice, very reliable systems like, the Aroa pallet loaders. These usually range, $250,000 all the way up to $750,000 depending on the model. This model in particular, all the Aroa stuff, I think is actually really cleverly designed, because unlike a lot of these robot in a boxes, they can hold a lot bigger machine loads, which really make sense if you have very high part weight applications, because this kind of layout's able to move a lot more weight around than what we would require to have a large enough FANUC or similar style robot to move that same amount of weight. But that said, all these systems, the pallet changers, all the way down to a just integrated cobot or robot solution, are going to have very, very high upfront costs, and also oftentimes a lot of hidden costs. So the next thing, and of course it depends on who you're buying the robot in a box from, but whether or not the cost is integrated upfront when you pay $100,000+, sometimes $200,000+ for the system. Generally, like the integration itself is going to be at least $20,000 of the cost of these robot in a boxes. I think something similar with the Aroa style and different aftermarket pallet loaders, just integrating it to your exact machine. And because all these systems, whether it's a robot in a box or an aftermarket pallet changer, are so relatively unique in terms of how they have to integrate with a given machine, whether it's a Haas or a Doosan or a Herco or what have you. Because of that, it's not just we want to sell this Haas machine and replace it with a Doosan. We'll just move, our robotic loading system from one to the other. Generally speaking, you're going to be spending $20,000+ with the original manufacturer, the OEM, to have a tech come out and do the actual swap over from machine to machine, if it's possible at all. And one of the other difficulties like this, or with the integration being such a large part of a pallet changer, or a robot in a box system, is that they also suffer from very extreme depreciation. So you might have an asset here that from a business point of view you spent $200,000 on, and you find out, hey, we want to replace this mill with a different one that fits our needs better. Generally speaking, a robot in a box system does extremely poorly on the secondary market, usually depreciating well over 60% of its value. And your options are basically to sell it for scrap value, or to go and pay $30,000+ on an already, hopefully at that point depreciated asset to have it reintegrated with the next machine. And then kind of the next thing I like to have everybody ask is, hey, what if standard automation doesn't work? This right here is a cobot at a facility we did a turnkey on. And they spent north of $50,000 to get this cobot integrated to make these parts automatically with an integrator. And the original project was a win, where they were able to make the parts automatically. Everything was going well. But what happened is when they moved to the next part number, I think the integrators, and this is a very common story with cobots, kind of oversold just how easy it would be for their existing staff to go and integrate this robot on the next part and the next part and the next part. And that's definitely less true with pallet changers and robot in a boxes, but especially when you get to standalone robot and cobot and pallet tending, part tending rather, where you're moving the parts individually one at a time. You really want to have the staff and the bandwidth where you have a dedicated applications or robotics engineer on your staff if you're going to make this work. And it's not to say you can't make it work on your own if you're small, but it takes a lot of time, it takes a lot of energy, and it takes a fair amount of skill and industry knowledge to be able to make, especially robot and cobot projects work, beyond the first project after the integrator has done their job. And this is probably the biggest one here. This last of the 4 big points with what I think are the standard automation industry's issues with these big robot pallet changing and similar industries solutions is, did you think about the tooling cost upfront that is coming along with one of these systems? So, if you have a standard pallet changer, did you think about just the cost of the base pallets? For something like a horizontal, those can be $5,000 plus just for the base. And then, on a horizontal, you obviously are going to need tombstones as well. On something like basically, any system that is living in the world of pallet changing, you might see one of these Trinity systems where you have $100,000 to $300,000 of just shrunk vices. And that is one of the really big downsides of using anything that is pallet based is the amount of work holding just turns out the amount you spend in work holding tends to be tremendous and often can rival or exceed the cost of the actual robotics integration. And then, really the last thing I encourage everyone to think about is, when you do get a quote from us for, in-machine automation, let's say we're doing a turnkey, that turnkey might come out, for full two-op automation to, $20,000 or so, hardware, software, CAM, everything included. And, usually around $12,000 to $13,000 of that is just straight hardware cost that even on the cheapest, cobot integration, you would still have to pay. And what I mean by that is, the way we leveraged in-machine automation, which I'll talk a little bit more in the next few slides, most of the upfront cost is actually just in the automated work holding, a couple automated vices, some kind of automated part flip station, and, essentially end effectors. But, we obviously are using in-machine automation, spindle grippers, vacuum grabbers, what have you. And because of that, what we almost always see is that people often miss the hidden costs of, looking at a cobot, because they say, oh, well, the cobot's $35,000. And they often miss that, hey, the end effector that you're going to have to buy, maybe you're buying the Robotique end effector for your UR arm. And then, you're going to buy an air vise and say, you don't buy our air vise, so you buy the shrunk air vise. And you buy a part flipper and you buy all these little accessories. Usually the accessories in the kind of given place of the market for automation are going to add up to more than the total turnkey cost of our entire integrated system. So, that's kind of what I see as the downsides of standard automation. But, really at the end of the day, the biggest thing with all automation, like the goal is to make you money, to get ROI, to make your production better. And ROI is hard when your system is $250,000. And especially if you're a smaller shop, if you're a cramp shop, if you're just in the position where you need more production, really what we're trying to get you is the ability to buy more spindles and still let you automate as opposed to buying, more robots. So this is a slide where I kind of like to joke, surely there's a better way. And if you can't tell at this point, I think that better way is in-machine automation. So, let me play this guy here. This is basically our bread and butter. What you're looking at here is the two-op automation pallet. And the two-op automation pallet, it's 2 of our brand of air vices with an integrated part flipper all on a single base. And then what you're seeing up here is a couple of rotary bypass grippers combined with our rotary bypass vacuum grabber. The idea here is that we're able to automate completely within the machine. So, rather than using end effectors that are on an expensive robot arm or, an expensive pallet changing system, instead, we just put something directly in your spindle that changes just like a tool. So it goes in your automatic tool changer. It's super simple to do. And one of the huge benefits of that is that there's zero complex robotics or integration. When we do turnkeys, and we'll talk more about this later, we do most of them as what we call semi-turnkeys, where we're actually just prepping everything, validating it on our own machines, and sending it to you, as opposed to having to physically come out to your site. And part of the reason that we're able to do this is because the programming itself, even when we're doing this complicated two-op automation, is fully automatic. The way that we're able to achieve it being fully automated is because we really have built out not just products in terms of spindle grippers and vacuum grabbers, but really what we see is a complete ecosystem. So, for instance, we make instant solenoid kits that allow for the pneumatic integration with the machine. We make, various kits and solutions, whether you need to flip the part, whether you need to increase the pressure, decrease the pressure, going into your lines. But then really the most important part of the ecosystem is on the software side, where what we've done is made a online program generator that is just free for anyone to access for one-op automation, and a very robust, completely automated template system where essentially we're taking a template and we're just giving it some key variables about your stock size, and everything runs fully automatically inside your machine. So the actual code that you're running is not any different for the individual subprograms that are machining your actual component than you're already running, and that allows you to get going for something like this full 2-op automation in usually around 2 hours or about 30 minutes for a 1-op automation setup. And all this really combines to allow us to give what we believe is the industry-leading system, both in terms of affordability as an entryway into automation, but also in terms of ROI. And that's one thing we really find as well, is that a lot of customers come to us saying, hey, we want an entryway into automation. And what they find is that we actually offer an end solution. A lot of customers think, hey, we're going to do this, then maybe later we're going to do a pallet changer or a robot in a box, and they find, hey, actually this $20,000 solution fully integrated, roughly $12,000 with just hardware, is everything that we need and more, and we can just copy paste this across machines. And really for the right shop with the right part, we really focus on existing production parts. Where everything's a slam dunk with our in-machine automation systems is especially if you're over at a bare minimum, I would say 50 parts per month, especially if you're over 100 parts per month. It's very, very easy. And generally speaking, we're going to get you ROI on that kind of a production job in the course of around 2 months, as opposed to 2 to 3 years of a traditional automation system. So, a little bit about us. We only do one thing, and we're really focused on it. We make fast ROI automation solutions for CNC vertical mills. We have people using these things on horizontals, on lathes, on all kinds of funky setups. But really, as a company, our entire mission is to bring automation to the masses and to really provide the best value industrial automation for CNC verticals. I really believe that just having operators there, hitting the button, loading a part one by one is a huge waste of human potential. I think that it's honestly a little bit of a boring job, and it's something that we can and should automate away. And I also believe, to be candid, that a lot of where the current automation industry is coming from is really trying to milk as many dollars from their customers as possible. Because I think, spindle grippers and solutions for automating within the machine have actually been around for a decent amount of time. But it's just made more sense for the big OEMs to sell you a $100,000 pallet changer, a $200,000 robot, than to give you a solution that can make ROI for you almost immediately. Really what we do is broken down into hardware sales and doing semi-turnkeys and turnkeys, where we're not just selling you the hardware to do the automation, but actually offering you a solution for your part or part family. A little bit more background about us. I like to say that we're big enough that we'll be here in 5 years' time. We support all of our products 100%. But at the same time, we're small enough that that we're always going to pick up the phone. We're going to be there, when you need us, and we really pride ourselves on world-class customer service. Really, where Gimbel Automation came from was that I was actually running parts personally for quite a long time when we were a production job shop, and I pretty much got tired of it. At that time, we were 4 people. I was the only one, because I hadn't hired a machinist yet, who knew how to run the mills. And because of that, I invented the first gripper that could run on what we call the bypass block. So that bypass block was basically the invention that bolted to the bottom of the spindle that passed air through a redirected route, so that for the first time you were able to use grippers, grabbers, and solutions without the need for through spindle air, through spindle coolant. We started selling those grippers. They took off, and then we started really building an entire ecosystem around, not just building spindle grippers, but now vacuum grabbers, pneumatic vices, conveyor loading systems, our best-selling 2-op automation pallet, and tons of pneumatic accessories. Our systems are used across, more machine brands than I can count. Compatibility, generally speaking, if you have through spindle air, it'll work on virtually any machine. If you have through spindle coolant, it'll work on any machine other than Haas, because Haas won't let you spindle orient with a spindle gripper or vacuum grabber with TSC on for whatever reason. And then for a limited number of brands, including Haas, Brother, Herco, as well as Fanuc, we make these rotary bypass grippers and bypass grippers that are able to run without the need for through spindle air or through spindle coolant entirely. We really have systems on everywhere in between incredibly tiny shops, one-man operations who are running lights out, automated, and just crushing it, all the way through, multi-billion publicly traded companies who are using these systems to move some very tiny parts and some surprisingly large parts. The other thing too that I really should mention is that, we really try to take a personalized approach when we're doing any work with your components. We will engage with you in any of these three ways, whether it's a hardware sale, which, you can just go onto our website, purchase everything. All of our pricing is completely public, so you can just, buy the product, exactly how much it's going to cost. Stuff typically ships next day, all the way through complete turnkeys where we're coming out to your location. We're fully validating and testing everything first on our own internal validation machines. But then, at the end of the day, before we leave, we're going to make sure it's all your parts or part family are running in spec automatically on your machine. And then, kind of probably the bulk of our business is actually the semi-turnkeys, where, we sell you obviously the hardware to make the automation possible, but then we design, test, and implement a, complete operational approach for your given part or part family. We fully validate it, test it, do everything in-house on our machines, and then send you a video and actually have you, the end user or customer, do the final install of the machine so that you don't have to pay a ton of money for us to come, on site, especially if you're just geographically far from where we're located. So, obviously too, because the majority of our business at this point is semi-turnkeys and turnkeys, we've really taken great lengths to basically create what I call, a productized service. So, obviously there's tons of integrators and very custom solutions that you can get in order to get an automation outcome. But what we've really focused on doing in order to give, best-in-class ROI is to bundle everything up into a very neat, constrained process. So, typically we start off with a 30-minute discovery meeting. Normally me or one of our sales reps would be doing this call here that you're presumably watching on YouTube or our website. And really that 30-minute discovery call, it lets you know everything you need to know about our automation systems, what they do, what they can do for you, make sure that they're a good fit. And then this usually culminates in us reviewing your parts. Typically, depending on the customer, there's often an NDA involved. So, we sign the NDA and then we have this meeting. And we go through, our solutions. And from there, really the goal is to get to the next meeting where we do a free turnkey proposal. So basically what is entailed in that free turnkey proposal, we're going to create a full beginning to end mock-up in CAD of the proposed solution. So, we would say, hey, maybe we want to use the 2-op automation pallet or this spindle gripper or this vise. We put it all, digitally in CAD on your machine table. So, we get the CAD from the OEM or manufacturer of your machine. And then, we give you exact proposal pricing. So we say, hey, this turnkey is going to cost X dollars. For a 2-op automation system, our cliche 2-op automation pallet, it's almost always just around $20,000, with about $12,000 or $13,000 being for, the actual hardware, and the remainder being for getting the entire part family or part, completely cammed out, built out, and the system fully validated. At that point, we collect a deposit. Once you sign off on this turnkey proposal, and then we start the in-house build and test process. So one thing that's really unique about how we do all of our turnkeys, whether a semi-turnkey or a full in-person turnkey where we're doing the install, we design, build, test everything on our own machines. So here in Los Angeles, we have 2 locations. We have kind of a dirty production location with our water jet and some of the dirtier machines like powder coating, and then we have our showroom location, which is also where we do engineering and process validation for turnkeys. And, essentially what happens is we take your part, we take all of our products, and we machine all the soft jaws for you. We machine all the gripper fingers for you. Whether if it's a custom implementation or, we're doing something extra difficult, we do all of that on one of 3 machines that are essentially just dedicated to turnkey validation. So those machines, they're all Haas machines right now. We have a UMC 500, a DC1 for the BT30, and then a VF2 YT. That said, we have the validation procedures that have ensured that those turnkeys work well across various brands. RoboDrill for Brother, Fanuc, or sorry, Speedio for Brother, RoboDrill for Fanuc, then Haas and Harco and DN and so on. So basically, what's going to happen with a semi-turnkey is once we have everything completely finished, which means that we're making your part automatically, completely under automation, reliably and in spec. And we're doing everything from the very beginning stock preparation through the fixture design, through the cam. Once we have achieved making your part completely within spec, we go and we take detailed video showing you that the automation solution is working, and only at that point do you pay the remaining balance on your semi-turnkey. And once that's done, we go and we create very detailed documentation, on how to install the thing, how to set it up, exactly where your instant solenoid kits go, exactly how your airlines are going to route, essentially everything that's going to allow you to put this thing together in a matter of hours. And this is kind of where we diverge a little bit between a semi-turnkey and a full turnkey. For the semi-turnkey, what's going to happen is that we ship this over to you with all this detailed documentation. You set it up, and then with almost every semi-turnkey, we include at least 4 hours of phone support. And that phone support is essentially usually used for 1 or 2 hours or setup questions, or hey, I have this question about how you implemented this thing, and then usually the other 2 or 3 hours are trying to get you up to speed so that when you're doing the next part, you don't have to rely on us, and you're able to essentially self-implement using all of the systems that we put in place, whether it's the program generator, the programmable macro template that we'll provide you, and get you up to speed so that you're able to now, say you want to copy and paste this across 6 machines, you're only going to be paying the hardware cost and not the turnkey cost. It is generally complicated enough, especially when you step up to 2 operation pallets, that we want to hopefully do that first turnkey with you so we can make sure you're fully trained. And then, obviously here, if you're doing the full turnkey service, we would come to your location, physically install everything, get it working, and wouldn't leave until everything's fully validated. And for a semi-turnkey, you would do this part yourself. And then this is kind of the final cycle that we like to get everyone into. We really have one of our core beliefs in world-class customer support. You really should be getting an answer from us quickly. I'm not afraid to hand out my personal cell phone number to our larger clients. We want to make sure that you're getting the right outcome for your individual parts. And then, of course, this is pretty common as well, especially in kind of the mid-sized shops. We generally are going to, for a shop that's say 10 to 25 people, most commonly those shops are going to, buy 1 2-op automation pallet, maybe solve a given part family or a given production part for them. And then at that point, usually they're just buying hardware, and maybe there's some after-sales support in like, hey, this thing broke, or I need a rebuild kit because this thing has run 250,000 cycles or what have you. And then for some of our larger clients, that's really where we tend to just do additional turnkeys, kind of project by project. It really depends on the client. And going back to that previous slide, we'll really engage with you, any way that makes sense for you. So, this is one thing that is really unusual that we do. You won't see this pretty much anywhere else in the industry. And this only applies to turnkeys and semi-turnkeys, but we guarantee return on investment of 1 year or less. And we also guarantee that we're going to personally handle all of your intellectual property. And if there is any subcontractors, which is pretty rare on projects, we'll disclose them to you. We'll make sure that they're under the exact same NDA that we're under. And really that only happens under niche scenarios where, say you have kind of an esoteric or less common machine, and we want to, send this to one of our subcontractors for further validation, that everything still operates correctly on that niche machine. But if that happens, you'll be fully aware of it. It's pretty unusual. But going back to the ROI guarantee, we literally will not sell you something that we don't think will make you ROI in less than a year. Typically, most of our systems are getting customers ROI in less than a couple months. And we're even seeing some customers with the right aerospace shop or the right component are literally getting ROI in the course of a couple weeks. Part of what's unique about the ROI guarantee is that because we have this, we literally won't sell you a system if we think you're not going to make your money back on it in a timely manner. There are some little caveats to our ROI guarantee. If you use this, basically we're going to give you all your money back But you have to demonstrate, or at least show us in good faith that you tried to use the system, and tell us why it didn't work. Because at the end of the day, if this is going to happen, we want to make sure that we're getting something good out of it for our next customers, so that we're able to continue guaranteeing ROI going forward. So this is kind of the slide where I like to get into the details about what is a spindle gripper, how does it work, what does it do. This is a spindle gripper here. Basically a CNC spindle gripper is just like an end effector on a robot, but really the difference is that it goes into your automatic tool changer, just loads into your spindle, and then the parts are loaded and unloaded completely within the machine envelope inside of your CNC vertical mill. What's really unique as well that we offer that no one else offers is essentially an ecosystem, not only just pneumatics, but also an automatic program generation system. As far as these actual spindle grippers and how they're actuated, we have our various bypass systems that don't require through spindle air coolant for about 4 or 5 brands. And then, of course, the completely universal systems for through spindle air and through spindle coolant. We also have some vacuum grabbers that use vacuum to load and unload. But generally, a spindle gripper is just going to be the most cost-effective automation solution that's available. Of course, you're going to be doing part tending and not pallet tending. So you're moving, individual components or individual parts, as opposed to moving entire pallets of parts, including the work holding, which of course is more cost-efficient, but has a little bit more of a misload risk, which means that we really want to make sure all the process is controlled. The biggest advantage, though, bar none, is that there's no robot, there's no system that really has to be integrated in any detail. As far as our program generator, you can go to our website right now, see how completely automated it is. You literally type in, what your XY spacing and quantity is on this XY grid. And for a given system, say a one-op automation kit, which is very easy to self-install, we sell this as a kit for less than $5,000. And then, for a 2-op kit, just the hardware cost, depending on whether it's through spindle air or through spindle coolant, that kit is $10,000 to $13,000. So, there's essentially nothing to really integrate. Everything is done directly mathematically in the machine control. But the biggest advantage, just blanket, with in-machine automation, is that you get to use the robot you already have. A lot of people really are concerned, hey, is this really my spindle meant to take these kind of loads? Is it meant to do loading and unloading? And why not use this over a robot? Of course, there's a huge, we like to answer that by saying, hey, the first thing, obviously ROI. The second thing, it's just so much easier to program when you're going through an automated system. There's no cobot to teach. There's no, hundreds of pallets. If you have the right part number in the right quantity, it's just usually a slam dunk. As far as the loads going onto the spindle, I also like to remind everyone there's usually thousands of pounds of force that your spindle is resisting mid-cut. Moving around a 5, 10, even 20-pound part using the spindle is literally nothing for the rigidity that your machine is built for. And then kind of the last thing I also like to remind people of in comparison, in specific, mostly to cobot applications as a comparison, we sometimes get concerns of, hey, how accurate are these end effectors? How accurate can my machine load components? And I like to remind everyone that your CNC machine is going to be orders of magnitude more accurate than essentially any system that would have a cobot anywhere involved. These CNC machines are holding 10,000 7-inch all day long, very, very great precision and very high rigidity. And, whereas a cobot, you'll be lucky to get, over a very long cycle, especially over several years, you'd be lucky to get, better than 25 thou accuracy after a couple of years of wear and tear. So, the system's also just more accurate and far more capable. And of course, there's no programming, to be candid, for the vast majority of small components, anything that can fit in a 6x6x6 inch cube or in a regular Kurt vise, in-machine automation is usually, at least in our opinion, the way to go over traditional pallet loading systems. You get a really big, heavy parts that are 50 pounds, parts that are outside the envelope that you could fit in a regular Kurt vise. That's where we really say, yeah, those are the parts that tend to make sense for a big, robot in a box solution or for a full-on pallet changing solution. So now I want to get a little more into detail about some of our specific automation solutions. And again, this is kind of our best-selling system here. This is the 2-op automation pallet. This is available with either 100 or 75 millimeter air vices and an integrated part flipper. This has actually been redesigned to be even more compact. So it's about 16.25 inches in Y now. And it's really designed to be put either on the left or the right side of a 3-axis machine table, kind of just like you would orient a 4th axis. This kind of works in conjunction either with part loading magazines, which aren't shown here, or a tray. This is kind of a custom cut tray, and we just lay out the parts in an XY grid, and the programming is essentially fully automated. Of course, the huge deal with this is you're able to achieve complete one-piece flow of your system, where you're making every kind of sub-cycle, because one cycle we're presumably making many parts, but every sub-cycle we're getting one complete part as the output, as opposed to making 20 op1s on some big fixture or pallet, flipping them all over and making doing 20 op2s. And then the next, this is kind of our flagship product, the conveyor loading system. The conveyor loading system is really unique. It is a little bit more niche. It's geared specifically towards the 5-axis market, and specifically towards machines that have an XYZ moving head. And the reason for that is because the way the conveyor system works is that essentially an auto door opens on the side of your machine or on the front of the machine. The conveyor comes in to the machine envelope, and then within the machine envelope, our line of spindle grippers or vacuum grabbers can grab a component from the conveyor, load the part, then the conveyor goes out, the auto door closes, then we machine the part to completion. Finally, we put the part back into the unload side, and then we rinse and repeat. What's really brilliant about this, again, everything's fully macro controlled, and we're basically starting out with an initial program template. Every single time we're essentially just doing the exact same operation, because the conveyor is delivering raw stock to the exact same location every time. There's not even any grid calculations to look at. So the math is even simpler, the implementation is even simpler. And one other thing that's really unique about the conveyor loading system is that it's essentially adjusted just like a woodworking fence. So you have one fixed side fence and one moving side fence. And because of that, because of how everything is set with the work coordinate systems, we basically only have to adjust an input, manually adjust for a change in stock size, and then in the program itself adjust the macro variable for the XYZ stock size. Everything else is completely automated. This really, bar none, is the easiest way to run automated parts. And the only caveat is that you need to have some kind of component, some kind of rectilinear or cylindrical surface that can go onto that conveyor and not tip over. This can be configured in kind of two main configurations. The first one is just basically relying on you to not only use good industry practices, but also to put in your own safety systems. So the first variant is obviously a lot less expensive, but it involves directly wiring into your machine and using the pneumatics and controls that we provide you to drive the machine directly via M code. And then the second option is considerably more expensive, but it's just a necessity for large enough shops that have ISO or OSHA or intense safety requirements. We can also and regularly do retrofit PLCs onto our conveyor loading systems, and then have light curtains as an additional safety lockout. As far as grippers and grabbers, we currently have 6 different models, and then various submodels within each of those models. We have the rotary bypass gripper, as well as a standard bypass gripper for some machines, but generally the rotary bypass gripper is the way to go. This is essentially the system that we invented to, with the bypass block, to allow passing air into the gripper to have it be actuated. But then we invented a secondary system with a built-in rotary union so that we're able to still spindle orient even with the use of the bypass block. This usually is what we're going to put onto essentially any machine where through spindle air, the addition is cost prohibitive or is problematic. Then this is just the straight bypass gripper. We're only really using this in niche scenarios now, where for instance, if spindle orientation isn't an option you have with the machine, that's the only reason we would really go to the bypass gripper. Of course, we make 3-spindle air and 3-spindle coolant grippers. The 3-spindle air gripper is just really universal. If you have 3-spindle air and you're wondering what gripper do you get, should you get the bypass block? Unless you need to do something special or you need really low grip force and you need to regulate it down, the 3-spindle air gripper, if you have the option, is always the way to go. It's the most cost-effective and generally the most flexible. There's nothing to calibrate or no bypass block to add. The 3-spindle coolant gripper is really great as well. Just a caveat for our Haas users, at least as of right now in late 2024, you cannot spindle orient with 3-spindle coolant on. So this really isn't an option, because one thing as well with the 3-spindle coolant, we have to allow some intentional leakage to drop the pressure to acceptable levels within the gripper body. So we're not just clamping a ton on your part to where we would mar it. And in order to do that, we have little openings where the coolant streams out. with a Haas in particular, if you can't turn on spindle orient while turning on TSC, that thrust from that coolant is enough to make the gripper rotate and potentially cause a machine crash. So if you are in that boat with Haas, you really want to go down to the bypass gripper route, or ideally just retrofit through spindle air on the machine. We also, on Haas machines in particular that already have TSC, can do that for about $1,200 on our end. And then lastly, we have the vacuum grabbers. We have these both in through spindle air, as well as a rotary bypass variant, so that we can go and still use vacuum to pick and place components and raw stock and finished parts, even if we don't have through spindle air. This is not available in a through spindle coolant configuration because inside of our CNC vacuum part grabber is actually a Venturi generator that is just based on compressed air and doesn't work with hydraulics. So I know I talked a little bit about spindle grippers, a little bit about vacuum grabbers. The vacuum grabber is really something that we try to get every customer who buys a gripper to also get. And the reason being is that it's just so incredibly easy to use. Even with the CNC spindle grippers, we're really the only company that's built them from the ground up for exclusively in-machine CNC automation of vertical mills. And, part of the benefit of that is that, it comes with a tool holder. It's guaranteed to operate the way you want. It's exactly for the application that you're trying to use it for. And then it also has these convenient universal plates that go onto the bottom of the gripper fingers that allow you to, insert these little fingers to very quickly and easily move between part stock sizes. That said, though, it's probably at least a 5-minute changeover to move those gripper fingers to the correct location when you're changing from part A to part B. The advantage of the vacuum grabber, on the other hand, is it's literally just a suction cup. If your suction cup has a big enough surface area to generate enough force in order to pick up your component, it's going to work from part A to part B. Really, we just have an 1/8-inch NPT thread in the vacuum body, and that also has the huge benefit of I can go on McMaster Carr or Masumi, and I can go through all of the various suction cup options, whether it's oblong or round or tiny or huge, and I can get the exact suction cup that I need for the application. We've seen all kinds of crazy things. We've seen these be extended, shortened. We have also made versions with multiple suction cups by just using a Y connector out the bottom. It's incredibly powerful and easy to use. And if you have viewed any of our demos of in-machine 2-op automation, you'll probably notice that in almost all of them, unless we're constrained on tool slots in the ATC, we're generally going to be using the vacuum grabber to load the op0, just the raw stock, into the op1 location. And then, once we have used a gripper to move into the part flipper, once we've flipped in the flip station, we'll again almost always use that same vacuum to grab just the flat surface on the bottom of the raw stock to load into the op2 location. They're just incredibly powerful. If you have very tiny parts or very large parts, the vacuum grabber is almost always a slam dunk, even over the gripper. For the very small parts, we can put a tiny little suction cup in there. Even we've seen custom machined vacuum dies for very customized parts or very precise locating. And if you have a very large part, even the standard 2-inch suction cup that's included with the kit, there's 4 suction cups that come just with the kit to begin with. Even that standard 2-inch suction cup will hold 25 pounds of component with a little bit of safety margin on it. So, generally for a calculation, we tell people, 8 PSI of vacuum per square inch is about what to count on. We actually generate more than that, but this is giving a little bit of safety factor. So, with a 2-inch diameter suction cup, you should be able to count on moving around 25 pounds of parts relatively reliable. Now, obviously, there's a little bit of compliance in that suction cup. We want to make sure that we have a reliable enough and rigid enough suction cup that, the part isn't able to tilt if the part starts to get too big. And then onto our air vices. We make a line of air vices. I'm sorry, that's old pricing there. In 100 millimeter, 75, and 150 millimeter. And we also make them such that with the 75 and 100 millimeter air vices, we have an optional rotary base plate that allows them to be implemented onto a 4th or 5th axis. Just a note that's fully compatible with the rotary provision, the through platter rotary provision from Haas, whether that's an HRT 160 or like a UMC platter. These vices are really neat because basically they're one of only a few vices on the market that have these little slits that allow the hard jaws to be moved incrementally in about 1 millimeter spacing. What that means is, like, unlike some of our competitors, air vices, you're not going to have to make a new soft jaw for every single component that you run into. For your op1 or op0, if you want to call it that, and you're just doing dovetails, you're going to be able to almost always just use these existing hard jaws. One other really unique factor with these 100 millimeter, 75 millimeter, 150 millimeter air vices, they all have springs built right into them. And those springs are going to start you off with a higher clamping force. So you can see the graph here of the pressure into the clamp line, and then the clamp force here on the y-axis in pound force. You can see that we're starting out right at 1,000 pounds. This has the huge benefit that if, for whatever reason you have pneumatic failure, the parts aren't going to go flying. They'll be held very rigidly in your vise. Most likely what would happen if you were to have pneumatic failure, you'd pick up another part, and then, generally, depending on the machine brand, especially if we're proving out a program, we're going to be loading at a really low feed rate in safe mode. So it would just try to load another part exactly on top of the other one and just air out without causing any damage on the spindle. But generally speaking, we do have some customers who want to get even less force. Say you're loading, Delrin, a very soft aluminum, brass, or soft jaws, want to mar the component. We can also remove the springs out in, depending on the model, there's 6 to 10 springs. We can remove, a portion or all of those springs to just bring this graph down just, linearly by the, the portion of the spring force that's been removed. So again, we sell these in 75, 100 millimeter, and 150 millimeter sizes. All these air vices are very high precision. We sell hard jaws and soft jaws for all of them. They're all steel and stainless steel construction. And then again, we have that rotary air vice system as well that allows you to put this directly onto a 4th or 5th axis platter. And that's the 4th axis platter here. Depending on the model, we may need some sort of adapter. But generally speaking, we should be able to bolt onto, especially any 4th or 5th axis platter designed by Haas for their air vices. We're going to be fully cross-compatible and generally far more cost-effective than those particular air vices. We also, as an aside, make the only system that's universal for a 4th axis rotor union that just allows you to pass up to 4 air lines completely through your center bore. And you can see here, we don't have any lines that are wrapping around. We're able to infinitely rotate. And this is one thing that we sell quite a few of as well. This is our flip station. The flip station basically allows the part to be turned over mid-process in the machine. We also have some upgraded universal gripper fingers that are generally used to load via the top hat as opposed to loading via the side of the component like you can see here in this earlier version. Really, the flip station is there if you don't want to go the route of the 2-op automation pallet, and instead you want to manually set everything up, buying one vise for, op 0, or sorry, for op 1 rather, a flip station, another vise for op 2, and so on. So this allows you to flip your components over midstream, and is really, one of our key differentiators that allows us, instead of just automating in machine for a single op and then having to do it all over again, we're able to deliver, a very lean process of single piece flow completely beginning to end. Kind of coming back to what I was talking about earlier with, we're trying to build an ecosystem, not just, an individual product. This is really one of those things. This is the instant solenoid kit. And essentially what the instant solenoid kit does, it just magnets to your machine. And then it has, little Phoenix connectors that, if you have a Haas or a couple other brands of machines, it'll just plug in directly into those connectors on your I/O board. And then that'll instantly give you all the control you need to control the pneumatics on the machine. And this is a single instant solenoid kit, has 2 integrated solenoids in it, and that's enough to do, a gripper and a vise. If you get into a more complicated setup, if we're blowing off air vices or if we're doing a 2-op automation pallet, generally you're going to need 2 or 3 of these things. But what's really cool about the instant solenoid kit, wiring in the solenoids to M codes, everyone thinks it's going to be really easy. Generally it's one of those like spirally tasks where, if someone has to figure out how to wire up a solenoid into a machine, they think it'll take 20 minutes, and it actually takes them 2 days. This is just a product that guarantees number one, complete optical isolation, so we're not running any current through your circuit board, and number 2 means that that the process is going to be reliable because all these are custom circuit boards and optically isolated. You don't really have to worry that one of your solenoids is just going to randomly fail one day. And then really other than ease of integration to integrate with all of our pneumatic products, one of the big selling points is that we have this pendant here. And this pendant, it's actually optional, so you can purchase it without it, but the pendant just magnets onto the front of the machine and has these, big red aviation switches that are essentially override switches. So what these do is, let's say that, you have everything set up for automated parts, you're running a 2-op automation pallet, but you want to just go and run, 1 or 2 test components. really what you don't want to be doing is going and typing in MDI, putting in the M code, hitting enter. Hopefully you have a machine brand that even lets you do that with the doors open, and then, loading a part and unloading it. Instead of having to do that, just to open the vise, you just flip the switch up, and the vise is going to stay open until the switch is put down. And this little red LED indicator, it's going to turn on when we're either activated from the M code or from the switch. So these override switches, these little pendants, make things so much easier to integrate when you're doing the initial setup. Because really it adds up typing in MDI over and over, and especially in those scenarios that we're going and we want to run components, say manually, but in an air vise. This lets you do this really easily. It also lets you manually actuate your gripper and various devices really easily as well. The instant solenoid kit, honestly, we're skeptical to sell any system without it because it just makes the install that much easier. Another kind of random note, we have tons and tons of people using these for 0-point systems, Pearson pallets, Pearson vacuum systems, shunt pallets, all kinds of pneumatic devices, people using them with air knives, people using them just for various little integrated systems. And really, you can use this as a replacement for almost any kind of standard OEM branded pneumatic control. Haas, Doosan, RoboDrill, Speedio, they all have these systems that allow you to kind of have solenoids purchased with the machine for additional actuation. But they're going to be $2,000, $3,000, $4,000. And the instant solenoid kit in this kind of standard configuration is $789, which to give you, two complete 5-channel or 5-way solenoid, 2-way solenoids. And they can be used either with on-off configuration of just turning an airline on or off, or for kind of double acting cylinders. So it's just a very, very powerful solution that's very, very easy to use to get M code control of your pneumatics. The last note as well, this can also integrate directly with a robotic system. The way that it's designed to work is basically by monitoring the state of the relays on the machine. We also have a 24-volt conversion kit, which allows us to work with brands like Brother and Fanuc, rather than just having to be limited to all the brands that are on relays. Luckily, that 24-volt conversion kit also means that if you do want to integrate with a robot, this is also a solution there. And then this is one thing we make as well. We make 2 different auto doors. On the left here, this is kind of our standard auto door. This is really geared towards an aftermarket option for Haas machines, but it'll work on most machines that have this kind of vertical plexiglass door. This is a very cost-effective option. It's purely pneumatic. It's really designed to be used in robot cells and similar systems, or places that there's caging because there's not sensors integrated into it. And then there's also our premium auto door you can see here. The premium auto door is honestly more popular. The benefit of this one is it's on genuine high-wind linear rails. It's still pneumatic, but also has provisions for sensors. And it has the very, very cool feature of being completely parametrically scalable. So all the parts here, we actually water jet them on our 5-axis water jet in-house here in Los Angeles, powder coat them in-house. It's made 100% here in the USA. And what's really unique is because everything's custom made and the design's completely parametric, we can just scale it up and down to your machine. It also has this neat little provision for being magnetically mounted. It really depends on the installation whether that's possible. Obviously the sheet metal has to be of a sufficient thickness and a sufficient rigidity to magnetically mount, but it is just a cool feature for the right machine. And in a lot of cases with the premium auto door, for a couple models of Haas and a couple other machine models, we don't actually have to do any modifications whatsoever to the machine. We're able to use the existing opening and actually leave the initial door that was already there in place in the open position. And like I mentioned earlier with the part tray, I think I showed you with the 2-op automation palette, we had an XY grid of the parts laid out. One of the big disadvantages of in-machine automation with spindle grippers can be the creation of these custom grids. And to be fair, it's not hard. Presumably, you're a machine shop, your production floor, maybe you're an OEM that's trying to integrate the system. The thing to think about is like, okay, well, we have to make a tray that holds all of our components, in even XY spacing. For very large production runs, if you're running 1,000 of a component a month, yeah, it's very easy to justify machining that tray. But we make this adjustable part tray for those applications and those customers. Say that you're just a production job shop and you don't want to make tons and tons of custom trays. What this lets you do instead is essentially, with these 2 layers of adjustable bars, we can put your parts in a perfect XY grid, and that XY grid can be set up just in a couple minutes. Generally, we're going to just put 15 thou of shim stock on the components on two sides to make sure we have enough play for the gripper and grabbing, so that we can easily load out of and into the various part tray slots. But really, this thing's super convenient. Just one note, they are built to order. So we build them for your machine table. So because of that, the pricing varies a bit. They are built bespoke, so we can make them go around, say something like an OTS probe, or we can make them go directly onto your fixture table, and so on. One thing I forgot to mention as well, both with this product and with the 2-op automation pallet, both of them are configured such that they can be put directly onto 0-point systems. The 2-op automation pallet actually has a 96 millimeter pull stud as standard on the base, so that we can drop onto a 2x4 pattern of a 96 millimeter pull stud, whether you're buying that from Fifth Axis, from Lang. I think Kurt is now starting to make those and is releasing those at IMTS. And we can do the same thing here. And both of those products, both the adjustable part tray as well as the 2-op automation pallet, because we build a lot of them to order, all of them in the case of the adjustable part tray, we can put on essentially any 0-point adaptation system that you want, or make them configurable such that they go into any hole pattern, whether you have a particular base from a fixture plate, rather, from Lang, from Saunders, what have you. And just kind of coming back, I think I mentioned earlier that we make a line of rotor unions. These are actually old versions, but the newest versions, we have a universal 4-port rotor union that is very unique in both how it's constructed and what it allows you to do. We really saw a gap in the market in that we had a lot of customers who were putting 1, 2, 3 vices onto a 4th or 5th axis, and we're having problems getting sufficient air to the vices themselves. And that's really why we pioneered this new product, a 4-port universal rotor union. What's really neat about it, it actually expands on the inside bore of the rotating area inside of the 4th or 5th axis platter. And that allows us to pass those 4 air lines totally through the bore with infinite rotation. And we're able to do that on essentially every single bore that's bigger than, I believe, like 1.1 inches. So we're able to do that by building very small custom rotor unions, and then also uniquely securing them into the interior bore of the product. What you need to know as a customer is that almost certainly the process here of checking compatibility, we'll get your model number of your 4th or 5th axis platter, and then from there we'll make sure it has a sufficiently sized bore, and then we go and custom machine the actual puck that's going to do the expansion on the inside of the bore, and then we'll provide that to you all as one single kit. And this is kind of a little bit of a non sequitur. This is actually a product that we developed for our own internal use. These are the automatic tumble baskets. We sell them in both a kind of smaller size, this is the standard size, as well as a giant configuration that's much bigger. Basically what these do is they go into a sandblasting or bead blasting cabinet, and the sandblasting or bead blasting cabinet, we put the gun into this mount. It's kind of a Noga style indicator mount with an adapter to hold on to the actual blasting gun. And then, from there, we just set the digital controls, and we have these baskets rotate. And what that lets you do is, if you have small components, we're really talking about components that are either lightweight or very hard, or aluminum, or we use it a lot for SLS 3D printed parts. It allows you to automatically process them. There are some caveats. Your parts get too big, they're going to bang into each other. So you have to make sure your parts are either light enough, or say small aluminum parts or small stainless parts. You don't want to be putting in big baseball sized components into these. But for the right customer with the right application, using an automatic tumble basket means that you're able to reallocate labor. If you were having someone spend 2-3 hours doing blasting these 100 tiny components, literally just turn the blasting cabinet on, set the automatic tumble basket, walk away, come back, turn the blasting cabinet off, and then all your parts are fully blasted. These products are super affordable, and for the right business with the right components, they're usually a slam dunk. So we're getting towards the end of the presentation here, but I just kind of want to run you through some of the typical packages that we tend to sell. The first package, this is basically the standard 1-op package, and this 1-op package is going to come with a spindle gripper, a 75 or 100 millimeter air vise, an instant solenoid kit to do the actual controlling of the air, and then also some airline. This is going to come in around $5,000 depending on the configuration. Obviously we have different options and for what gripper and what grabber you want to use, but generally speaking, this is going to be our most popular kind of entry-level package. The huge benefit of it You're literally taking the instant solenoid kit in, plumbing in the air lines, mounting the vise, putting the actual gripper or grabber into the machine, and at that point, you're pretty much ready to run automated parts. For one-op automation, generally we don't even try to do turnkeys with this because it's so straightforward that you really should be able to do it on your own. It's very easy to understand and very easy to get automated for one-op. Where it gets a little more complicated is here with the two-op automation. And with this two-op automation, you can see what's going on here. This is actually a dummy part of a component that we ran for an aerospace shop. So this part's actually been simplified and dumbed down a lot. But basically, you can see here what we're doing is, we have a part tray. We grab the component, put it into the op1, do the machining. With the gripper, move it into the part flip station, flip it over, put it into the op2, fully machine, and then put the part back. With a two-op automation pallet, the actual quantities that are necessary to run in order to make financial sense and get good ROI out of it are a little bit higher. We're going to be kind of closer to the 100 parts a month threshold that you can run through the system to get really fast ROI out of it. The thing as well to understand with a two-op automation pallet, it's really easy to use once you understand it, but there's definitely a learning curve there. Unlike the one-op automation palette where everything's super intuitive, everything's super easy, we do have to get you to post out code correctly from the different work coordinate systems here and here, and we have to get you to set in total 5 work coordinate systems to run the system properly. Once you understand how all the WCSs work, how to post out code, how to make sure that the chips are cleaned out of the system by using a coolant washout or chip fan, then it's really easy. But for that reason, with the two-op automation palette in particular, we usually like to start almost every customer off with a turnkey so that, when they're going in and doing either their second job with their existing two-op automation palette or they're putting an additional system onto the next machine, they're able to do that without having to depend on us to do, the programming and get everything sorted. Instead, they're able to just self-implement using all the tools, including, the macro template and everything we provided them. And then package 3 is really the conveyor loading system. The conveyor here is, really the first thing to note, we do build them to order. The reason we build them to order is essentially because we have to make sure that we can go through the correct machine size or the correct door size. Some customers are willing to just cut out the entire section and put in a large auto door to handle bigger parts. Some customers, some brands of mills, like Hermla comes to mind, we can only even go through the front because the sides are actually integrated into the casting, but we're still moving the head in that XYZ Cartesian space. So, because of that, each one of these is a little bit of a custom implementation, and we have kind of 3 or 4 variants where we pick and choose the best one for you, and kind of, get the package all set up. Generally speaking, with the conveyor loading system, we're going to get you one gripper, and or one vacuum. Generally we try to do both. The instant solenoid kits are going to be included, and those are on kind of the base versions of the conveyor loading system going to be what's actuating the actual conveyor, and everything's going to be M-code controlled. The package contents are going to change a little bit when we're doing the PLC integrated stuff for an ISO or an aerospace shop, because we want to make sure that we get the PLC in there, we get the light curtains in there, and then everything's fully safety locked out. All right, so now I just want to go through a couple of the most kind of standard questions that we tend to get. The first is, how's the programming done? And that we actually split into beginning users and advanced users. So for beginning users, we always run them through this M97 program generator. We have a new version coming out of this for this, hopefully pretty soon here in the next couple of months, that's going to allow this to also work on machines that aren't M97 compatible like Fanuc and Brother. But nevertheless, for the machines that are M97 compatible, essentially what you do is you pull this open, you put in your XY pattern quantity on your XY grid that you saw earlier, and then we set the tray work offset to the bottom left corner. So the center bottom of the first tray location. And there's detailed articles and documentation, so I'm just trying to run you through this quickly. And basically, you go and you put in your machine code, just delete out the M30, and you hit generate. And once you've done that, it spits out the complete beginning to end code, and that code is what you're going to upload as your NC file onto your machine, and it should just work. That said, we do have some editable areas of beginning code, end code, chip cleaning code that are going to vary machine to machine. This code here is really just configured for the kind of the standard user on a Haas VF2, and we can provide you When you buy, even a small package from us, a vise and an instant solenoid kit and a gripper, we're generally going to provide you at least some beginning information on what to input into the program generator and make it work for you. Now, if you're on a more niche machine brand, or most commonly, if we're doing things as a turnkey, or even if you're just buying the 2-op automation palette, we're going to move you over to our free macro template. The free macro template is much more powerful, and the biggest thing that it's able to do that the program generator online cannot do is that it's able to do complete, beginning to end 2-op automation. So, if you're running the 2-op automation palette, if you're doing something more complicated, this is the route that we have to run you through. It is a little bit more difficult to get your head wrapped around. And part of the reason it's more difficult is we've gone to incredibly great lengths to make it as universal as possible. So for the most part, between, Fanuc, Herco, Brother and Haas and a fair number of other brands, we're able to run just this one type of template, which means, we had to make the G code go, be written in such a way that it's able to run across this wide variety of machine brands. Everything is done completely mathematically inside of the control. And really, with the macro template, we're setting the gripper offset as a tool height. We're setting maybe the vacuum offset as a tool height. We're setting, if you're doing a 2-op automation palette, about 5 work coordinate systems, and we're just doing that one time. And then all we have to give it is our XYZ stock size and a little bit of information about, how much material is being removed. All the math, all the part loading, all the gripping and grabbing and movement locations are being totally done mathematically inside of your machine control. So, you don't have to worry about how this thing's going to get loaded. You don't have to worry about programming the gripper or the vise or what have you. That's going to be done, at least in a template form that you can start with if you are just buying the hardware. But hopefully, most likely the cleanest route is that you just start out with a semi-turnkey and you let us do all the hard groundwork of figuring out, hey, you have this brand, so you have a Smart or you have, a Robo Drill. We probably have seen that exact configuration before, and we can, make sure that you have the exact correct M codes that are configured for the way that you option the machine from the factory so that this thing runs every time. And again, when we're doing a turnkey or a semi-turnkey, one of the big benefits for you is that we're guaranteeing an outcome. And because we do everything on flat fee, that means that we're able to essentially, guarantee the system is going to operate rather than just giving you, here's some hardware. And if you don't have the, the applications engineers or the bandwidth to figure it out, the thing that we hate to see is we hate to see our products sit on shelves. And that's really why we've gone to such great lengths to make sure the programming is easy to do and completely automated. So the next big question we get is, what about chips? And this one's kind of funny because, the first thing is, I always kind of turn that around because people compare, the what about chips question with in-machine automation to the what about chips question with pallet changing, with robot in a boxes, with, individual cobot loading and unloading. And the reason I turn that around is because it's the exact same extent of the exact same problem that all these other systems have. Sure, maybe it's a little bit less with a pallet loading system, but, a chip in the wrong spot can still cause problems. And I like to remind everybody that this is essentially a solved problem. On the right machine, if there's sufficient coolant flow, I really think of, like a Brother machine, a Fanuc machine, or even, the Haas now has the DC series of machines that we have one in our facility. All those machines have sufficient coolant flow that we've literally never seen chips be an issue in machine automation. And generally speaking as well, all of our systems are going to have a chip washout procedure that is going to clear out devices and ensure that there's no chips in any problematic areas on essentially every changeover step. What that means is that chips are very unlikely to be the issue, and when they are the issue, they should really be caught in the first really setup validation step. That said, there are some machines, especially the entry-level machines. I'm thinking Haas or Seil, kind of, standard bread and butter, 3-axis machines where the coolant washout really isn't sufficient. And in those cases, we just go straight to a chip fan. To be honest, we don't love going to chip fans because they atomize the coolant. We really prefer that if we're using a chip fan, that the facility have, some kind of mist collector on the machine. But, that said, they're incredibly effective. They get all the chips and the coolant right off of the system. And, if you have one of those machine brands, I'm really thinking of it's the biggest problem with the Haas VF series, a VF1 through a VF5 or a mini mill. If you have one of these brands that the coolant flow isn't sufficient in order to wash out the chips by just, spraying the coolant over the vise, in that case, we'll know that and we'll tell you, hey, you need to put a chip fan here. And especially if you do it as a semi-turnkey or a turnkey, we're going to essentially include that in the package and make sure that everything is all sorted out for you. And then the next big question we get asked is, hey, what about organic shapes? How do I do an organic shape? And it's kind of the same thing here as it is with that same question with a cobot or robot or part tending system that isn't an in-machine automation solution. And the answer that we give to that is actually pretty straightforward. You know how to handle those complex shapes already as a machine shop or production facility or OEM because you're making soft jaws, presumably, right? If you're making organic shapes, if you're making things that are complicated, you're probably making soft jaws or fixtures already that follow those contours. And really all we have to do is the exact same thing onto the gripper fingers. And you can see we've done that here. So this is one of our demo parts. It's a bottle opener with an intentionally arbitrary shape. And we're showing here, hey, all you have to do is essentially cut away that exact arbitrary shape in the bottom shape of a gripper on a left hand and a right hand side. And now we're able to manipulate that part super easily. So you don't have to think of it as we can only do round or square or really regular shapes. You have to think of it as, hey, if this is a reasonably designed component that can be machined and that we can hold in a soft jaw, chances are we just take that same soft jaw geometry, put it on the bottom of the gripper, and it's going to work. And again, the last thing I like to remind everyone of is if you're going down the semi-turnkey or turnkey route with us, as part of that turnkey or semi-turnkey, we're going to have figured all of this out. Really when we do that, we're guaranteeing an outcome. We're trying to get you a solution for your production and your part family. We're not just trying to get you, a gripper and say, figure it out. So it's relatively easy to figure out, depending on the quantity. If you're doing, say, 1,000 parts in the total run, that we can use a Bamboo Lab FD3 filament 3D printer to do it. If you're doing 10,000 parts in that run, we can use, a Mark Forged carbon fiber filled filament and do the same thing. If you're doing 20,000, we can do, in-house on our turnkeys, we can SLS 3D print these. And then, kind of above those kind of numbers, we really just need to go to aluminum or fully machined soft jaws so they can handle the wear. But, regardless, again, this is kind of like the chip question. It comes up a lot in kind of our normal course of FAQ. But that said, it's almost never what limits the ability of spindle grippers and grabbers. And it's one of those things that you always are going to have the exact same problem regarding, doing the loading and unloading, regardless of where it is in any kind of automated system. With a different part loading system, you're still going to have to make, soft jaws or custom gripper fingers that go on the end effector. And with, even a pallet changing system, now you're just making 100 soft jaws, which is, in my opinion, kind of a blunt force solution, and just making one set of automated part tending jaws, 3D printed or machined seems much more elegant. And that's the conclusion. Sorry I ran a little bit long, but I had a lot to say. Obviously, if you can't tell, I'm very excited about in-machine automation. I'm a big believer in how it can get you ROI really quickly, what it can do, especially for the right shops with the right machines. Just as a reminder, we really specialize and believe in, and our sole focus is in machine automation for CNC vertical mills. So, if you have any questions, feel free to reach out. You can also go ahead and book a free 30-minute discovery call where I promise I won't be nearly as in-depth as I was in this video, so we can keep it nice and short and focus on your parts and your application. And if you just go to gimbelautomation.com, which is GIMBEL automation.com, you can go and book a discovery call right there. Awesome. Thanks so much. Bye.